Okay, this is a quick lesson over how to solve exponential equations that are in a quadratic form. So if we look at this first equation we have here, e to the 2x minus 7 e to the x plus 12 equals 0. We should notice that this first term is squared, the second term is linear, and the third term is a constant. So we can kind of think of this. Let's use a little substitution here. Let's say that n is equivalent to e to the x. So what we're going to do is we're going to substitute an n wherever we saw an e to the x. So this could become n squared minus 7n plus 12 equals 0. So now you can clearly see that this second equation is a quadratic. So we took the equation here and wrote it in a quadratic form. Now this factors simply to x minus 3 times x minus 4. Excuse me, not x, these are n's. And we said that n had a value of e to the x, so now that I've completely factored it, I really can think of this as e to the x minus 3 times e to the x minus 4. So we know that this product must equal 0. So for the product to equal either 0, either of these factors must equal 0. So e to the x minus 3 must equal 0, or e to the x minus 4 must equal 0 for the product to equal 0. So we can solve these simply. Move the 3 over. And because it's base e, we'll take the natural log. And when we take the natural log of this side, we get the natural log of e. The x comes out in front. And the natural log of e is just 1. And then we'll take the natural log of this side. So x equals the natural log of 3. Or, here we get e to the x equals 4. We take the natural log of both sides. And so this side simplifies to x. This simplifies to the natural log of 4. So our solutions are x equals the natural log of 3 or the natural log of 4. Now, some of you may have said, okay, well, I see this quadratic form up in this first line. So can I go straight from here to here? Certainly. If you see this quadratic form, don't use n substitution. It is handy if you don't see it, but if you do see it, go straight from the first line down to the fourth. Let's take a look when our base is not e. Example 2. Here we have 2 to the 2x plus 4 times 2 to the x minus 12 equals 0. So here we're in base 2, but here I see a squared term, a first term, and a constant. So it's an exponential that's in a quadratic form. So if I use n substitution, this time n substitution, n would not equal e to the x. It would actually equal 2 to the x. So this would be n squared plus 4n minus 12 equals 0. So it factors to n plus 6, n minus 2, and because I used n where I had a 2 to the x, now I can plug back in 2 to the x and solve these. Now if we look at this first factor, you may already see it. When we set it equal to 0, we're going to look at this and go, okay, what power do I raise 2 to get a negative 6? Well, there's no way to raise a positive base to a power and get out a negative number. So for this part, there is no solution. But let's look at our second factor and see if that gives us any answers. And you may already see it. 2 to the x equals 2, so x has to be 1. So this equation has one solution. It is x equals 1. Okay, let's try another one. Example 3. For example 3, here we have e to the 2x, excuse me, plus 2e to the x minus 15 equals 0. So once again, our base is e. If you'd like to use n substitution, you certainly may. But you may just be able to go ahead and factor this to e to the x plus 5 times e to the x minus 3. And once again, if we look at this first factor, when we set it equal to 0, we get e to the x equals negative 5. So we don't have any solution here. There's nothing I can raise a positive, e is approximately 2.71, to a power and get out a negative number. So we look at our second factor and see if that gives us any solutions. So here we go. E to the x equals 3. Take the natural log of both sides, and we get x equals the natural log of 3. Okay, let's look at another one. Example 4. Here we have 3 to the 2x minus 5 times 3 to the x minus 14 equal to 0. So hopefully we can all see that our n, if we used n substitution, would be 3 to the x. I'm not going to put it in. I'm just going to say this is 3 to the x. And if I'm factoring, this is 3 to the x. Excuse me. Yes. 3 to the x, and 3 to the x times 3 to the x gives me the 3 to the 2x. Okay. Now, what can I multiply that will give me 14? That's 1 and 14 and 7 and 2. So I'm just going to play with it so that I get my middle term correct. So if I made this a plus and this a minus, I want it to end up being negative, so I'm going to let that 7 be negative and the 2 be positive. That's a negative 21 and a positive 6. Does that work? Okay. I'm sorry, that's not what we do. It does work. If we used m substitution, we'd see it clearly. That does give us the negative 5 and the negative 14. So we set this one equal to 0, and this factor equal to 0. And so we get 3 to the x equals negative 2. There's no solution there. 3 to the x equals 7. All right, so on this one, we're either going to write it in log form, where we would switch forms, and this would become log. What is my base? 3. What is my answer? 7 equals x. Or I could take the log or natural log of both sides, and I could write my exact answer as log of 7 over log of 3, or natural log of 7 over natural log of 3. So if we wanted exact answers, any of these would work. Okay, let's take a look at 2 more, and then we'll be done. So let's say we have 2 to the 2x plus 1. So this one's a little different. So 7 times 2 to the x equals 4. So this one's not equal to 0. So our first thing we're going to do is move this 4 over, so it'll become minus 4. Now it's equal to 0. Now we haven't done one that said 2 to the 2x plus 1. But this plus 1 we could write as 2 to the first times 2 to the 2x. Because when we multiply like bases, we add the exponents. So if you wanted, we're going to sneak in n substitution just so you can see this clearly. We'll let n represent 2 to the x. So this becomes 2n squared minus 7n minus 4 equals 0. And we can factor that to 2n plus 1 times n minus 4. And so this is 2. Here my n is going to equal negative 1/2. And here my n is going to equal 4. Well, is there any way to raise a positive base and get out a negative number? No, so that's not going to work for me. And then here I get this. And what power do I raise x to? The second. And the last example I have for you today involves one that doesn't factor. E to the 2x minus 5e to the x plus 2 equals 0. So if we used n substitution, we're looking at this. And you can clearly tell that this one does not factor. And when a quadratic doesn't factor, we have to use the quadratic formula. So we would say n is equal to negative b, so it's going to be positive 5 plus or minus the square root of b squared, which is 25, minus 4 times a times c all over 2 times a. Well, n is really e to the x, and I should have written this out here. N equals e to the x. So e to the x is equivalent to 5 plus or minus the square root of 17 over 2. And so to solve, we would take the natural log. So we would get x is equal to the natural log of 5 plus 17 over 2, or the natural log of 5 minus the square root of 17 over 2. And those are our examples. We'll be going over these on Monday.